Hello water managers, I'm Fauwaz Hanbali with the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to cover the HEC-MetVue overview presentation. In this part of the presentation, I'll give you an orientation on key features in HEC-MetVue. I'll talk about how HEC-MetVue reads and aggregates data in time and space, and how it computes basin average statistics. I'll highlight the main tools for saving output. I'll also talk about other HEC-MetVue features, including data reading and manipulation features, as well as features for time zone and metadata handling. When a data set is loaded into an HEC-MetVue map window, the data set gets aggregated temporally. And the default display is an aggregate statistic tin for the time window of the data set. All of this is done in memory, so the original data set would be preserved. In this example, when loading 24 hours of an hourly precipitation data set, HEC-MetVue automatically computes the precipitation accumulation over 24 hours. And that one-day total precipitation tin is displayed by default in the map window. At the same time, the user can still scan to any particular time interval or animate the data set hour by hour. Taking another example, if 24 hours of a temperature data set were loaded, the default aggregate statistic tin will be the average temperature for the day. Now, there are user options to change the default statistic. Those options include the maximum or minimum over the entire period of the data set. Lastly, I want to highlight that the temporal aggregation is based on the data type. HEC-MetVue recognizes the data type from the input, and based on the data type, HEC-MetVue determines what appropriate statistic tin to compute and display. HEC-MetVue can also compute basin average statistics on the fly. There are two required inputs for that. One is a meteorological dataset, like a set of precipitation or temperature grids, and the other is a basin shapefile. You can see in this illustration there are 4 days worth of precipitation grids loaded over a basin shapefile. As soon as the precipitation grids are loaded, HEC-MetVue automatically computes and displays the aggregate or total precipitation depths and corresponding volumes per subbasin. As you can imagine, having this information instantly is very helpful, especially to get a quick idea on observed or forecast conditions for areas of interest. Additionally, one can save basin average time series per polygon from a basin average shapefile. So for any designated basin average shapefile, the Save Time Series tool can be used interactively to write out basin average time series to DSS. And optionally, a text summary report can be written out as well. Looking at the example here, highlighting the Spring Creek subbasin, the aggregate basin statistic display gives a nice idea about a 4-day rain total, averaged over the Spring Creek subbasin area. At the same time, the output time series gives the basin average rainfall every hour during the 4-day period. And the basin average time series is especially helpful to see the temporal variation of the data per time interval. Writing out gridded data is also possible, especially when modifying the gridded data set, such as clipping extents or applying adjustment factors. For cases like this hypothetical situation where the aggregate grid is translated and rotated, the output gridded dataset would need to be reprojected using the Save and Project Grid tool. Hypothetical translation and/or rotation of a gridded dataset is typically done to look at the potential outcome of the intense portion of the forecasted storm hitting a nearby area of interest. Spatial aggregation of gridded datasets is another capability in HEC-MetVue. For example, if there happens to be different sources of datasets that cover different parts of an area of interest, the MetVue reader has an option to combine the grid sets both temporally and spatially at the same time. If the different datasets have some spatial overlap, as you see in this illustration with 2 green gridded regions overlapping in the middle of the Susquehanna watershed, there are options in the MetVue reader to average the overlapping values, or take the maximum or minimum values in the overlapping area from the different grid sets. The Save Tin or Grid tool can then be used to output a grid set with the maximum extents that cover all the combined data sets. And null values, as shown in blue in this illustration, would be assigned to any non-spatially overlapping portions of the combined grid set. There's quite a bit of gridded data editing and analysis tools in HEC-MetVue. There's animation, which is very handy for visual analysis, and we'll look at that in another part of the presentation. But the main editing tools which are available in the toolbar include the Draw tool. That's the first icon shown here from the right. The Draw tool allows for freehand drawing of regions over the data set, and that can be used to either apply extents clipping or apply measurement value adjustments. The Resize tool, the icon to the left of the Draw tool, allows for expanding or shrinking spatial extents of a grid set. As tempting as it might be to use this tool, I do caution users to only use it in modifying data sets for testing purposes and testing purposes only. For example, if a proper data set is not available in the early stages of developing and testing a hydrologic model, the Resize tool could be used to help take an existing data set and expand it to cover the full extents of the watershed. Again, just for testing purposes. The other two icons to the left are spatial translation and rotation tools, which we touched on their applications a little earlier. Just to add, it is possible to translate datasets temporally. Essentially, changing the dates and times of a dataset can be done through the use of the grid save tools. For the rotation tool, there are 4 options to pick from for the center point of the rotation. There's the option for user-specified coordinates for the center point of rotation. The other options let MetVue determine the coordinates of the center point of rotation, as you see here. First, the map window center is determined for zoom extents. On the other hand, the tin or grid geometric center is determined based on spatial extents of the data, while the tin or grid weighted center would be skewed towards the higher value points of the dataset. Typically, the geometric and weighted centers are easier options to work with rather than choosing the map window center, unless the grid is centered within the map window. In any case, the rotation feature does provide visual guides showing where the center point of rotation is and showing the angle of rotation from the north axis. Let's talk about the data readers in HEC-MetVue. The 2 main readers are the HEC-DSS data reader and the TIN data reader. The 2 readers are very similar in features, but the main difference is that the TIN reader is intended for the selection and listing of non-DSS input files. Here we're looking at the DSS data reader. The DSS file selection is in the top part of the reader, and at the very top, the default setting is to aggregate gridded data temporally. But if needed, the spatial aggregation option could be selected, or the option to do both temporal and spatial aggregation can be selected. There are 2 options for selecting DSS records. The first option allows the user to manually browse and select DSS records from the catalog, while the second option is to let the reader find and select variable records based on specified criteria. Criteria like a specified date range or time interval for the grid set, like hourly or daily, for example. And the most important criteria is the DSS record path name filter, which has fields that are text searchable for partial or whole text, including through the use of wildcards. There are additional read options, and I want to highlight the extent read constraint option. As you can see here, when that option is checked, you can launch its dialog to define read extents based on either specified rectangle lat-long coordinates, or you can let MetVue figure out the read constraints based on the shapefile selection. Here's an example when read constraints are helpful for products such as Prism, whose default extents cover the whole country. One can limit the read extents of the dataset to the desired region or area of interest. Again, the read constraints can be specified manually by the user with coordinates, or MetVue can determine the read constraints based on the area limits of a selected shapefile. And it is possible to create a Polygon shapefile directly in HEC-MetVue. you can use the draw tool to define the desired extents for clipping the data, plus use the context menu option to save a shapefile. Then the shapefile can be selected in the data reader to apply the read and clipping constraints. Shifting gears here to time zone handling. HEC-MetVue recognizes time zones when available from the input dataset. Most meteorological data products are in the GMT time zone, but the user can set MetVue displays to a local time zone. And it's also possible to have MetVue convert the time zone of the input data and output in another time zone. Sometimes the metadata of gridded products lacks time zone information. In that case, MetVue will assume a default time zone of GMT, but the user can override the time zone setting in the data reader if needed. When data is read in an HEC-MetVue project, the Properties window displays the available metadata. Metadata such as time zone, time interval, units, data type, and the associated coordinate system. MetVue also adds other useful information in the Properties window, in particular the range measurements in a gridded record and number of points in a grid. HEC-MetVue supports working with a slew of meteorological variables, from precipitation to temperature and snow, to sky cover, wind, solar variables, and more. MetVue does need the input products to have reliable metadata in order to interpret and work with the data appropriately. Quite often, unfortunately, meteorological products are lacking in metadata, in particular the interval or duration of a record. A number of the supported data products in MetVue have required metadata overrides and are included in the data product list. Users can add to the list other products that need additional metadata inputs through the supported data definitions editor. This is the end of this part of the presentation. If you have any questions about our software, need some help, or are looking for additional training, please check out the links below, and thank you for your time.